Welcome students, welcome to Physics World by Sudhakar. We are solving some problems which have appeared in JAM, IIT JAM exam in previous years. Okay, one such problem is a gas of molecules each having a mass m is in thermal equilibrium at a temperature capital T. If Vx, Vy, Vz are the Cartesian coordinates of the velocity v, then the mean velocity of Vx minus alpha Vy plus beta Vz whole square is. Okay, he has given some options like 1 plus alpha square plus beta square plus kt by m into kt by m, 1 minus alpha square plus beta square into kt by m, like that. 4 options are given. Okay, what is he asking? The mean value of Vx minus alpha Vy plus beta Vz, where alpha and beta are some constants. Okay, right? Is asking. Now, there are a few things we should understand before going into the solution of this problem. Okay, according to the kinetic theory of gases, gases are made up of atoms or molecules which move randomly here and there. Okay, they are constant random motion, they are colliding with themselves, they are colliding with the walls of the container. Okay, so the average value, right, molecules like fitted in a cylindrical vessel fitted with a piston, molecules are in constant random thermal motion, colliding with themselves, colliding with the walls of the container. Okay, at any instant, probability of finding a molecule going towards positive x-axis is same as that going towards negative x-axis. Okay, right, the molecule, right, half of the time it will moving towards left, half of the time it will moving towards right. So expectation value or average value of x component of velocity will be equal to 0. Similarly, the probability for the molecule to move up along y direction, right, move down along y direction is also same. So average value of Vy, similarly average value of velocity of z component, okay, Vx equal to Vy equal to, right, Vz is equal to 0, right? Okay, expectation value or average value of the x component of velocity, y component of velocity, z component of velocity will be 0, because velocity is a vector quantity. When it is moving towards right, I'll take it as positive. When it is moving towards left, I'll take it as negative. So average value will become 0. Okay. Next one, according to kinetic theory, the Boltzmann's law of equipartition of energy, the average kinetic energy of a molecule per degree of freedom, okay, per degree of freedom is half kT, right? Half kT, where K is Boltzmann's constant, T is the absolute temperature. Means if a gas is at an absolute temperature in thermal equilibrium, the average kinetic energy per molecule per degree of freedom is half kT. Okay. Now here the molecule has how many degrees of freedom? Molecule of a gas in a container has 3 degrees of freedom because it can freely move along x-axis or y-axis or along z-axis. Okay. So half, what you call half kT is the average kinetic energy per molecule. Okay. Right, per degree of freedom. So right, I'll write like this: half m Vx square is equal to half kT, or Vx square average value is equal to, right, kT by m. Similarly, average value of Vy square also is equal to kT by m, right? Average value of z component, right, Vz square also will be equal to kT by m. So Vx square equal to Vy square average value equal to Vz square average value will be equal to kT by m. Okay, right? Now, what is he asking? Vx, the average value of Vx or expectation value of, what did he ask? The mean value of, that is nothing but average value, Vx minus alpha Vy plus beta Vz whole square. Okay, it is like in the form of A minus B plus C whole square. Okay, or A plus B plus C whole square you take. What is A plus B plus C whole square? A square plus B square plus C square plus 2AB plus 2BC plus 2AC. Okay, so A square means it is nothing but Vx square expectation value. Okay, alpha V. Now what is happening? A square, B square, C square you write. Okay, B is nothing but minus alpha Vy. Okay, that is nothing but, right, alpha square Vy square. So, right, Vx square plus, okay, Vy square, alpha square Vy square plus beta square Vz square expectation value, Vz square expectation value. Okay. Vz square expected value plus a square plus b square plus c square, okay, plus 2ab means 2vx into vy. Vx average value of vx is 0, average value of vy is 0, so 2vx vy is equal to 0. 2bc vy vz also will be 0. 2ca vz vx also will be equal to 0. So the remaining terms will become 0. Okay. So what is Vx minus alpha Vy plus beta Vz whole square? Which is nothing but Vx square, alpha square Vy square plus beta square Vz square. Okay. Now what is Vx square? Kt by m. Vx square is Kt by m. Okay. Alpha square into Vy square is also Kt by m. Beta square into Kt by m. Okay. So if you take out all these things, okay, so Vx square is nothing but Kt by m plus alpha square into Kt by m plus beta square into Kt by m. Okay, Kt by m you take common, 1 plus alpha square plus beta square into Kt by m. Okay, this is the option you have to verify. It is the first option A. So the answer is A, 1 plus alpha square plus beta square into Kt by m. Okay, this is one way of solving such problems. Okay, now next we see one more problem. Another problem is an aluminium plate of mass 0.1 kg at 95 degrees Celsius is immersed in half liter water at 20 degrees Celsius, kept inside an insulating container, and is then removed. If the temperature of water is found to be 23 degrees Celsius, then the temperature of the aluminium plate is, okay, dash degrees Celsius. This is a numerical answer type question. Means you have to find out the answer and put it there. Okay, right? Now, what is the data given? An aluminium plate of mass of aluminium is equal to 0.1 kg. Okay, temperature of aluminium is T equal to, right, 95 degrees Celsius. Is immersed in half liter water at 20 degrees Celsius. So mass of water he has not given, simply half liter he told. Okay, later on we have to find what is the mass of half liter water. Okay, temperature is, right, I am writing it as 20 degrees Celsius. Then what happened? Means here the aluminium plate is not placed inside the water and left such that both will come to an equilibrium. No, it has been inserted for some time and has been removed. Okay, during that time the temperature of water has risen from 20 degrees Celsius to 23 degrees Celsius. Okay, what happens to aluminium plate's temperature? Temperature has to obviously decrease. Okay, so what is the present temperature of aluminium plate is asking. The data is given is specific heat of water, specific heat of aluminium, and density of water is given. Okay, why did he give density of water? He said half liter water. Okay, 1 liter water is equal to 10 to the power minus 3 meter cube. 1 liter means 10 to the power minus 3 meter cube. So density equal to mass by volume. Okay, so mass is equal to, right, density into volume. Okay, density is given as 10 to the power 3. Okay, density of water is 1000 kg per meter cube, means 10 to the power 3 kg per meter cube into, what is volume? Volume is half liter. 1 liter is 10 to the power minus 3. Half liter is half into 10 to the power minus 3. That is equal to, mass is equal to half kg we will get. So mass of half liter water is half kg. Okay, right? Now, okay, now what is happening here? There is water at 20 degrees Celsius. I have immersed one aluminium plate from 95 degrees Celsius. At 95 degrees Celsius, it is been immersed in to the water. Okay, water's temperature has increased. Why did it increase? Because somebody has given its heat energy. Where from it got its heat energy? From the heat lost by the aluminium plate. So heat lost by the aluminium plate is equal to heat gained by water. Okay, what is heat lost by the aluminium plate? Heat lost by the aluminium plate is delta Q equal to mc dt, right? Okay, mass of aluminium into specific heat of aluminium into temperature rise. So what is mass of aluminium given? 0.1 kg. Okay, into specific heat of aluminium is 900 joule per kg Kelvin into temperature. Initially its temperature is at 95 degrees Celsius. Now its temperature will decrease to some point x. That x we have to find. Okay. This is the amount of heat lost by the aluminium. Where is that heat going? That heat is going into water. That's why water's temperature has increased. Okay. What is the heat that went into the water? Okay. Right, and cause it that 3 degrees Celsius. How do you write? I'll call it as delta Q1, delta Q2. Okay, is mass of water is nothing but half kg into what is that? Right, density of specific heat of water is 4,200 joule per kg Kelvin into its temperature. The change in temperature is what? Its temperature has increased from 20 to 23 degrees Celsius. That is, change in temperature is 23 minus 20 is nothing but 3. Okay. This is 2100 into 3. Okay, this is joules, right? This must be equal because heat lost by aluminium is equal to heat gained by the water. Okay, I'll equate these two things to find out the value of x. Okay, that is 0.1 into 900 is 90 into 95 minus x is equal to 2100 into 3. Okay. Right, 10 gets cancelled, so 95 minus x is equal to 210 into 3 by 9 will be there. Okay, this is nothing but 3 3s are 370s. So 95 minus x is equal to 70, right? Or x is equal to 95 minus 70. X is equal to 95 minus 70 is equal to 25 degrees Celsius. This is our answer. Okay, so you have to put 25 degrees Celsius. Okay, right? This has appeared in previous JAM paper. Okay. Next problem. One more problem. A solid melts into a liquid via first order transition. Okay. A solid is melting. Basically, the process is a melting process. The relationship between pressure and temperature in the transition is P equal to minus 2T. P equal to minus 2T plus P naught. P naught is a constant. The entropy change ds equal to 1 joule per mole Kelvin. Okay. The Clausius-Clapeyron's latent heat equation is L equal to T into dP by dt into delta V. Okay, where delta V equal to V liquid minus V solid is a change in the molar volume during the phase change. The correct statement relating the values of volumes is, okay, option A is VL equal to Vs, means volume of the liquid equal to volume of solid, volume of the liquid equal to volume of solid minus 1, volume of the liquid equal to volume of the solid minus half, or VL equal to Vs plus 2. Okay. Sometimes, right, you will find in JAM exam, right, the questions are very lengthy. Okay, nearly containing 5-6 lines. You have to read them. To read and understand the problem itself will take a time of nearly 1.5 to 2 minutes. Okay, after that you should understand the problem correctly. You should have the right approach. You should solve the problem, right? Write the answer, get the answer, and put the correct option. Okay, this is problem is right looking, right? A very time-taking problem. To read only it is taking a lot of time, but whenever a problem is very big, solution will be very small. Remember that. Okay, when the question is only one sentence question, the options make you think a lot. Okay, in some BHU exam, HU exam, statements will be very simple, just half line or one line statement only they will give, but to choose the right option, you have to think a lot. Okay, here simply reading the problem is the time consuming one, that's all. So solution is very easy, right? We see now a solid melts into a liquid via first order transition. It's understood. Okay, the relation between pressure and temperature is, okay, P equal to, right, minus 2T plus P naught. P naught is a constant he has given. The entropy change ds, right, ds equal to, what is ds equal to in general? Delta Q by T. Okay, general formula for change in entropy is equal to 1 joule for mole Kelvin. Okay, that's the data given. Okay, the Clausius-Clapeyron's latent heat equation, he gave it as L by T into, L equal to T into, right, dP by dt into delta V. Okay, where delta V is nothing but V liquid minus V solid. Okay, right? The correct statement relating the values of the volumes is, what is delta V is asking. Okay, delta V equal to VL minus VS is what relation it is satisfying. Delta V we need to get. Okay, delta V we need to get. Means what? This is what we want. Okay, so we have to have dP by dt. We should know T, we should know L. He has not given any temperature. Okay, and he has not given the latent heat also. Okay, now what do we do? But one information he has given, P equal to minus 2T plus P naught, and change in entropy ds by dt, ds equal to delta Q by T equal to 1 joule per mole Kelvin. So from this, try to find out dP by dt relation. Okay, if you differentiate this equation with respect to T, what do you get? P naught is anyway constant. So dP by dt will be equal to minus 2. Okay, dP by dt is equal to minus 2. Now, ds equal to delta Q by T. During first order transition, whatever heat we are giving is known as latent heat, that we have seen in Clausius-Clapeyron's latent heat equation. So this delta Q is nothing but L. Okay, so ds equal to L by T equal to 1 joule per Kelvin. Okay, L by T equal to 1 value that is given. So right now here what is happening? L by T is equal to, right, dP by dt into delta V. L by T is nothing but 1. Okay, how do I know L by T is equal to 1? Okay, delta Q is nothing but, right, L only. That he has given directly as 1 joule per Kelvin. L by T is equal to 1 joule per Kelvin. So 1 is equal to, what is dP by dt? Minus 2 into delta V. Okay, therefore, delta V equal to, right, minus half. Delta V equal to minus half. Okay, so delta V equal to minus half means VL minus VS is equal to minus half, or what is the relations given? VL in terms of VS is asking. So VL equal to, right, VS minus half. This is our answer. VL equal to VS minus half, right, is C is the correct option. Okay. Right now, though the problem takes a lot, more than 1 minute, 1.5 minutes to read, to understand what he has given, what is he asking, it consumes time of nearly 2 to 3 minutes. Okay, but solution is very easy. Okay, but sometimes some questions, right, the question will be very simple, but to find out the right option, you have to think a bit. Okay, example, I'll show you. Okay, now this one. In an infinitesimal adiabatic process, the work done is simply one line statement, that's all. In an infinitesimal adiabatic process, he did not specify whether it is adiabatic compression or adiabatic expansion, nothing. Simply said, small adiabatic process. The work done is, what is the work done? A perfect differential, is not a perfect differential, is 0, depends on temperature. Okay, in an adiabatic process, heat given to the system or taken from the system is 0, isn't it? Work done is not 0. You have to expand means the gas has to push the piston up. You have to compress it means you have to do some work on the piston, isn't it? So work done 0, this option can be eliminated. Okay, now whether it's a perfect differential or imperfect differential, go to the first law of thermodynamics, says that delta Q equal to du plus delta W. Okay, in an adiabatic process, you are not giving any heat or taking any heat. So delta Q equal to 0 implies what? Du equal to minus delta W. Okay, that is whatever the small amount of work done, delta W, right, will put that minus sign to this side, you will get minus du. U is a perfect differential. U is, internal energy is a perfect differential, right? So delta Q is equal to minus du. Means if you do work done by the system, if the gas pushes the piston up, internal energy decreases. Put that minus sign here. Okay, minus delta W means work done on the system. Whatever work you do on the system, internal energy increases. Is internal energy a perfect differential or a imperfect differential? You choose the option for yourself. Okay, now let us go to another problem. Right here, this is also one line statement only. Okay, if W is the work done on a system in a reversible process, W is the work done on a system on a reversible process. Which reversible process is not specifying. Okay, and delta F is a change in its free energy. delta F is the change in its free energy, then that work done is greater than delta F or work done is less than delta F or work done equal to delta F or work done not equal to delta F is asking. Okay, not equal to delta F. Now, to answer such questions, you need to understand the subject conceptually. Okay, once you are thorough with the concepts of free energy, okay, you can answer these problems by just looking at them. You can answer. Okay, try to take this as an homework. Okay, try to take this as an homework. Think. Okay, go through our previous videos where we have discussed about free energy, thermodynamic potentials. Okay, work done will be equal to which type of free energy, etc. Right, you can answer this question very easily. Okay, right, we'll see some more problems in the next video. Thank you.